Yeah. Sorry. I love that. I should just leave that on there like that, right? Next class comes in and be like, there isn't a next class. But when we moved into this school, when we first moved in, for the first like 4 or 5 years, there was this sound. If you went into the science office like had this like, right? And it always like nobody would work in there, and it has like these fluorescent lights and stuff like that. And it was like walking into the set of like Das Boot, right? You know, and I came over here and realized that there's a great big heating cooling system right above the science office, right in this middle section there. Giant system. I go up there and like practice speeches and stuff, right? And there's like a room. There's that door across the hall goes upstairs, and then you can like there's this hidden space there, right? And what they had done is they had actually, when they ship those units, they bolt them to their base. But normally when they sit in a building like this, they ride on springs so they don't shake the building, right? Well, they still were bolted to the building, right? And so it was just sitting there shaking the building, like making this like virtual earthquake. Ooh, cat-like reflexes. We didn't get them. We were trying to get you specifically in general. That's kind of fun, huh? Yay. They took the bolts off, and that office no longer has the... Okay, so you do this one. You guys do this one. Exactly the same thing, right? You got to figure out what the wavelength is, then figure out what the frequency is. How about you crack out a calculator and write an answer on a whiteboard? That's right. Huh? Yeah, what units for your wavelength? Yeah, you got them both. You got it, yeah. Yeah, what units does your wavelength have? Yeah, there you go. Oh yeah, that works. Ray, look at him. Man, good eye. Nobody's like walked into that yet.
Where were you?
Adidos. Yeah, it would round to 277. Yeah, that's right. Oh, do you have 2.76?
Did you think they're going
It's centimeters. Notice it's centimeters I'm giving you. So it's So it's 277. Yeah, is that what you have? Okay. 2.76 hertz, right? For the frequency. It actually would round to 277, I think. But bellissimo. So this whiteboard is so 0.62 is and then yeah, what units for your frequency? Oh, you have them there. Yeah. Is that 2.77? You missed the centimeters. Look out for the thing there, yeah. No, 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 no. Oh. Yes, yes. Everybody's getting 277, aren't they? Yeah. Yeah, this is good. Not 2.77. Oh, you put it at an angle, okay. Are you trying to get Kelsey? We should lower, actually just lower it slightly, right? She'll just like think she'll sail under it. It'd be better to just keep it straight but lower it subtly.
Oh yeah, neck level. Put it at the feet. At the feet would be so bad. Now you have to tell the people to offer to like walk. Put it like right.
No, but I just want her to think that she like got shorter while she was going to the bathroom. Or taller. There we have it. Yes, taller at the bathroom. You do get a little taller, right? Because you lose weight, so then your body rebounds from there. Are we ready for the next one? Is there a next one? All right. No, not so much. Okay. Put the caps on your pens, and if you write this down on your notes, I would use a page of notes for each one of these. If you write these in your notes and you have the detailed thing, you have something to study for the skill set for the test, right? This will be like the ultimate study sheet, right? So the first one is a violin string. And I know some people are against violins. But anyway, when you draw these guys, make sure your strings are all nice, the same length, right? So this is like directly below that, right? And draw your monokini, your bikini, trikini, a trikini.
I've seen one of those.
That's right. On the planet Zorg. And then this thing is 0.32 meters long. And I'm going to go into like, meter mode here. And the velocity is on this string is 281.6 meters per second.
See, that was at our eye level though.
Sorry, I'm short. I can also see it, but
That's true. You were suspecting it was there.
Yeah.
Did you notice we lowered it a little?
Yeah.
Oh, darn. Okay. So, and by the way, the 281.6, this is the speed of like that a ripple would go along the violin string, right? Now, this is too fast for us to see, yes? Okay, so the ripples actually go, this would be actually a very cool time warp to see. Like you tweak a string and then the thing like shoots along. Did you guys ever see the time warp where they did the, like hitting a cymbal, right? Yeah. And the cymbal like gets this big dent in it and then it, moves out like that, right? It's just amazing that drummers will just bend the thing. It's like that, right? So this speed here, you'll figure out very shortly why I picked that speed. I didn't just pull it out of the air. I know that violin strings are 32 centimeters long. I know what frequency this string should have, and I worked it backwards. Okay, so go ahead and do the next step is to find the wavelength, right? How many quarters? 2 quarters, right? So 0.32 meters is 2/4 wavelength, right? So the wavelength is what? 0.64, right? And then what's this guy? How many quarters here? Yeah, it's all, there you go, right? So 0.32 meters, I'm going to keep it the same, right? It's 4/4 wavelengths, right? So lambda is just 0.32, right? And these are all meters. Right? How many quarters here? This is this quarter, right? So 0.32 meters.